Hey, D-Dykster here. Another great math video for you. This time we are solving polynomial inequalities. Alright, so let's check it out. We've got some basic steps for us here. So let's go through these real quick and just try and decipher, well, what are we doing with these? Well, in an inequality, again, we are looking for something that's greater than 0 or less than 0, or any inequality is what's greater than something else or what's less than something else. A lot of times we'll be dealing with these polynomials and they're quadratics, so maybe they're parabola. And so what we're going to do is we're going to find out what is the interval of where the x is, where the parabola is less than 0 or maybe greater than 0. So we're looking to extend what areas beyond the x line where they will be less than or equal to 0, and then less than or greater or equal to 0. Okay, so what do? First thing what we have to do is we have to organize the polynomial in descending order. So for instance, an x cubed, x squared plus x plus c, that will help us with factoring and a lot of different things that come about with organizing them in descending order. Next thing we want to do is we want to get all of the x terms and the constants over to one side of the equation if possible. Right? Again, that will help us set us up for factoring, and we're starting to recognize where things are either greater than 0, positive values, or negative values. All right, once we have all the x terms and the constant on one side of the inequality, the next thing we have to do is factor. So we can factor to find all the x values, or in some cases we can just set f of x equal to 0 and solve for those x values. Those x values will be important values as we start to build a table and then build a number line to find the solutions that satisfy the inequality. Then we create an interval table. We can input test values. Okay. Then step 5 finally is we draw a number line to represent the table and the intervals that satisfy the inequality. Okay. So let's look at a first example here. We have x squared minus 5x is greater than negative 4. So, according to one of the steps, yes, it looks like they're so far in descending order, but they're not all on the same side of the inequality sign. So what we have to do is we have to add 4 to this side. So once we do, we'll get x squared minus 5x plus 4. And we're asking, where is that function greater than 0? Now, we know it's a parabola, so it comes down. There are parts of it that are greater than 0. When does it, after it crosses the x-axis, what interval of values is it positive or greater than 0? Well, if we factor this, we can easily factor it. Negative 4 and negative 1, that adds to negative 5, and negative 4 times negative 1 is a multiple, so that is positive 4. We set each of those intervals equal to 0, so we get x minus 4 is equal to 0. And we get x is positive 4. And we get x minus 1 is equal to 0. We get a positive x equal 1. Now what I'm going to do is I built a table of information here. So now what we'll do is we will fill in our table, and then we'll go down and complete our number line. So initially, all we want to do is we want to pick a number that, because we know if we plug in 4, that will be greater, or will be equal to 0. But what we want to know is, when is it greater, all this greater than 0? So what we can do is choose a number afterwards. For instance, 5. If I want to choose a test value of 5, right, then what I can do is I plug this in. 5 minus 4 is a positive number. 5 minus 1 is a positive number. So everything that is 5 and above or greater than 4 will yield us a positive value. Now, we go to the middle. What is between 1 and 4? Right? So we look at between 1 and 4. A test value might be 2. Well, if I plug 2 in, 2 minus 4, well, that's going to be a negative number, right? That's going to be a negative. And 2 minus 1, that's going to be a positive. So that's when we have a negative times a positive, I get a negative value. And I'm not too concerned what the x values really are. What I'm concerned about is, does it make it a negative value or a positive value? Because again, the inequality just asks, is it positive? Where is it greater than 0? Meaning it's a positive number. Now for our last one, I'm going to choose 0 as our test value. So if I plug 0 in, okay, if I plug 0, that's going to be a negative value, right? 0 minus 4 is a negative value. Negative 1, that's another negative. But look, once I multiply a negative times a negative, I get a positive. All right, so that's my basic table. Now what I want to do is I want to extend that. Created the table. Now I want to extend that to a number line. So in our number line, what we can do is say, well, they wanted to know, when is this positive? When is it greater than 0? So I know that this is positive. That's going to be greater than 0. So, but I'm not including 4, right? So 4 is here, but if I include 4, then it's equal to 0. So I will draw an open circle, and I will face it that way, right? 1, well, 1 is, if I include 1, that's going to make it equal to 0, but I don't want to know where it's equal to 0. I want to know where it's greater than 0. So again, I will put an open circle there, and anything beyond here will make it qualify. So there is my interval, and there are different ways you can write this interval notation, but the open circle means not included, and if they had an equal sign here, I could put a closed circle and be included. All right, let's go to the next example. Example number 2 says x squared, where is that? Less than or equal to 4x plus 21. Again, we get everything on the same side of the equation. And now x squared minus 4x minus 21, where is that less than 0? Okay? Or equal to, right? Now we have the equal sign. So x minus 7 and x plus 3. So we are the factors. X minus 7 is equal to 0 is 7. X plus 3 is negative 3. So I label my negative 3 and 7 over here. So if I want to choose 8 as a test value, right? 8 minus 7 is a positive number. That's a positive number, so this will be a positive value. If I want to choose 0 in here, that's a negative value, right? And a positive value, so that's a negative. And then if I want to choose negative 4, because that's less than negative 3, then if I go negative 3, well, negative 4 and a negative 7, that's another negative number. And that's another negative. Negative 4 plus 3 is a negative. So that will also be a positive once they're remultiplied together. So again, with our number line, what we can do is this time we're equal to 7, and we want to know, is it less than 0? Right? So this time we're less than 0. But we can include 7, and we can include negative 3 because it says equal. So I'm going to go ahead and fill in my circle here. Fill in my circle there. Right? And then what we can do is draw a line in between because that is the interval for which it is negative. Okay. Example number 3. Here we go. So this time we've got 3x squared plus 16x. Where is that less than negative 5? Well, again, we move everything over, so we get 3x squared plus 16x plus 5. Where is that less than 0? And now what we got to do is we got to factor this. Well, I'm not sure how many of you are familiar with, there's various ways to factor. I know one of our favorite ways here is if I take a times c, that's 3 times 15, and I put that up here. Right? So I'm going to just shift over here a quick second. And now we get, scoot this way a bit. Yeah. So now we put the b value 16, and then down here is the division X method here. I know that there's some people that are highly advanced at factoring numbers. I'm just going through the motion with you so you can see it. What are two numbers that multiply to 15 and add to 16? Well, that's 1 and 15. And so one of my factors becomes 3x plus 1. And you'll notice that this simplifies, and the 3 will go into the 5. And so that just becomes x plus 5. Now what I can do is set these equal to 0. 3x plus 1 is equal to 0. And after we subtract, we get x equals negative 1/3. X plus 5 is equal to 0. And once I'm done with that, I get x is equal to negative 5. So my two values are negative 5 and negative 1/3. So now I'm going to test those values. So I'm going to come down here, negative 5, negative 1/3. And in this case, it's not equal to, but I want to know where is it less than 0. So I have to choose some values. Well, the next obvious value over here would be a 0, right? So if I plug 0 in, well, that's going to be 0 plus 1, 0 plus 5. That's a positive value. Let's say I choose a point in here. Let's say I go negative 2 as a test value. And now negative 2, well, that's going to be a negative, but that one is going to remain positive. So that will be negative. Let's say I choose negative 6 on the outside. Negative 6, well, that's going to be a negative value, and that will be a negative value. So in that case, I will have a positive. So once again, we can see that where we want it to be negative is in here in the interval. Okay, so again, it's less than, not equal to, so I'm going to have an open space there and an open there, and then I will connect those two that way because that is the interval for which we have a negative value. All right, and basically what that means is if you were to graph this parabola, you would see that the x values, where it crosses the x-intercept, would be at negative 5 and negative 1/3. And you would see that the parabola would dip below the x-axis here. And that's all we're saying is, where are the y values negative? Where are the y values below the x-axis? All right? So, hope that helps. That's a great little way to do some of these solving inequalities, is the table and then subsequent linear method to show the representation. All right. Anyway, I hope that's been a great time. Thanks again. This has been Solving Polynomial Inequalities. D Dykstra out. Peace. Thanks. Keep it mathy.